Welcome to an introduction of Digital Globe's OpenSpaceNet software. My name is Kevin McGee, and I'm a software developer working on Digital Globe's machine learning project. In this video, we'll give a brief overview of what OpenSpaceNet is, what it can do, and we'll also go through a quick example of how to use our user interface. OpenSpaceNet is our easy-to-use software that enables you to automatically detect objects in satellite imagery using the latest machine learning technology. OpenSpaceNet is powered by DeepCore, our machine learning framework, which takes care of all the machine learning complexities so you can quickly integrate OpenSpaceNet into any project you're working on. OpenSpaceNet is available to download for free on the DeepCore website at digitalglobe.github.io/DeepCore. This is what OpenSpaceNet is capable of. We were able to give it an image of the Atlanta airport, and in seconds it was able to automatically detect all of these airplanes and showed in a format that's easy to understand and analyze. And we're not just limited to airplanes. OpenSpaceNet is capable of automatically detecting virtually any object, even objects as small as a car, because we have access to Digital Globe's archive of high-resolution imagery to train our models with. Now I'd like to go through a quick example of how to use the software. You can follow along by going to the DeepCore website and downloading OpenSpaceNet, as well as some free sample data. Here is the OpenSpaceNet user interface. It has everything you need to run our algorithms over the imagery you provide. At the top you'll see the current mode OpenSpaceNet is in. Currently we only support the detect mode, but expect additional modes to come in future updates. Next you'll need to provide the image you want to scan. You can easily access our web tile services by changing the image source. For this example, we'll be importing our own image locally. Just click the Browse button and select the image you'd like to scan. I'll be using the Atlanta airport image from the website, but you can use any image you'd like, as long as it's geo-registered. Next up, you'll need to provide the model file. A deep learning model simulates the way the brain processes images in order to detect objects. It uses a series of mathematical operations that analyze the content of the images in order to find objects of interest. For example, the airplane.gdbxm file you can download from the website was trained to find airplanes in satellite imagery. The next input you'll see is confidence. This depends on the model you are using, but this option will filter the output based on how confident the model is that it correctly detected the object. For example, if you have the confidence set at 95.0, the results will be filtered so that only results with a confidence score equal to or greater than 95 will be returned. This parameter may need to be adjusted based on the model you are using, but 95.0 is usually a good starting point to get some clean looking results. You can lower the confidence if you aren't getting the results you were hoping for. Next you'll see Windows step. This parameter is used in our detection algorithm. After you load your model, this field will automatically be filled in for you. If your detection results aren't what you expected, specifically when looking for smaller objects like fighter jets or vehicles, you may want to lower this parameter. Next, you'll see NMS. This is another parameter used in our detection algorithm that clusters the results. We recommend you turn this on and leave at a value of 30 for cleaner results. If you notice that there are multiple detection boxes for the same object, you can reduce this value to deter that from happening. Next up is the bounding box. For local images, you can generally ignore this as the software will automatically get the bounding box of the image you put in. If you have an area of interest within the image and you know the bounding box, you can click the override button to enter your adjusted bounding box. Next is the output format. These are geospatial file formats that can be used in GIS systems. We currently support shapefiles, GeoJSON, and KML. We'll use shapefile for this example. Next is the output file name. This is what the name of your output will be. We'll call this one Atlanta Detections. Next, you'll need to choose the output location that you want to save your file to. Just click the Browse button and select the folder you want to save the output to. Next is geometry type. OpenSpaceNet has the capability to output either detection boxes or points. If you want detection boxes drawn on the object, you should select polygon. If you want points, you should select point. You could ignore output layer and leave it blank. We recommend keeping producer info on, as this will just attach additional data about who created the shapefile. Finally, you have your processing options. There are two types of modes, GPU and CPU. The software will run much faster in GPU mode, but if we detect that you do not have a GPU, we'll automatically lock you into CPU mode. In order to use the GPU mode, you'll need NVIDIA CUDA capable hardware. Max utilization is a percentage you'd like your GPU or CPU utilized to. So if it's set at 95, then 95% of your GPU or CPU will be used during the processing. So if you'd like to do other tasks while you wait on the software to finish processing, we recommend lowering this number. Window size is another parameter automatically set when you put in your model. We don't recommend changing this value unless all other parameter tweaking has failed. Now we're ready to run. Simply click the Run button and a progress window should pop up. Just wait for the image progress and detection progress to complete, and then you're done. You can then open up the image and shapefile results into a geospatial tool like QGIS to view your detection results. If you have any questions, please feel free to contact us using the contact info found on our website. If you have any issues with the software, please log them onto our GitHub repo. We firmly believe that machine learning is the answer to solving many of our geospatial big data problems. With over 100 petabytes of digital globe imagery and growing every day, it's a big problem. But with your help, you can shape the future of machine learning for geospatial big data. Thanks for watching.